Hello guys, in today's video I'll be solving a question about the binomial distribution in the context of the program IB Math AI standard level. If you happen to study such a program, make yourself comfortable, this might be useful to you. So I'll be showing you the plan of work, I'll show you what to pay attention when you read the question to solve it effectively, and obviously I will guide you with a calculator. The question I'll be solving now and in my future videos will be all exam style questions and eventually actual past paper questions. So with that being said, follow me along on my blackboard and let's start solving. Okay guys, so here's the question I was referring to. Let me read it out. In a particular high school in Victoria, Australia, the probability of being left-handed is 0.475. In a class of 15 students, find the probability that, question A, exactly 8 students are left-handed. So let me guide you through the thought process of this question, okay? Let's keep it light, keep it simple, nothing too complicated. First of all, when you have questions with probability, because there's so many concepts about probability theory, there's tree diagrams, there's simple probability, there are probability distributions, you need to know what are you referring to. In this case, you are referring to the binomial probability distribution. How do you know that? Well, here's how you want to think about it. You have the probability of being left-handed. Let's call that L. Well, being left-handed is an option out of two possible options. The other option is to write with your right hand. The moment you have two possible options for a given event, that's when you know you're going to be using the binomial probability. So in this case, writing with your left hand is considered so-called success, okay? And in binomial probability distribution, you need to use the probability of success. So probability of success is equivalent to the probability of being left-handed, which is 0.475, okay? So we start from here. Then you need to follow the structure. Every single question you solve in IB Math is following a structure. So for instance, you know, or you should know, that you're gonna start solving the following way. You write your variable L, which stays for the student being left-handed. This is the variable. It's a discrete variable. Why is it discrete? Because you can only have integer values. You can have 2 students, 4 students, 9 students. There's no way you can have 8.4 students. Okay, so this is a discrete variable. It is binomially distributed. That's how we show it, with a B bracket, and you put the number of trials and the probability of success. So in this case, L is binomially distributed. The number of trials is basically your sample size. In this case, you have 15 students to consider. That's your number of trials. You put 15, comma, the probability of success we just discussed, 0.475. So you write that 0.475. With that being said, you start solving. You're going to be using your calculator. You should be having a graphic display calculator. So you want to know the probability of having exactly 8 students. Write what they are telling you. Probability, bracket, that your L, the number of left-handed students, equals to 8. You put that, and then when you go to your calculator, you have to know what probability distribution you're gonna choose, and we already discussed. You use the binomial probability distribution. So on your calculator, you go for the binomial distribution, and you want to choose binomial PDF. Okay, you want to use the binomial PDF. Why is that? Because you're gonna have an exact value. If you have an exact value, such as L equals to 8, you're gonna be using the PDF. Later in the question, I'll show you when you also have to use the binomial CDF, but that's for later. For now, click and choose your binomial PDF on the calculator, and it's going to ask you for the following things. It's going to ask you for N, it's going to ask you for the probability of success, and it's going to ask you for the X value. Well, the N is the number of trials, which is 15. The probability of success is 0.475, and X is the value that you put in the bracket here, which is 8. So in order to answer the question effectively following the structure of IB, you have to write binomial PDF bracket, and you put all these values in an order as you see from the calculator. 15, comma, 0.475, comma, 8. You do all that, you should be getting the answer of 0.183 rounded to 3 significant figures. The answer to part A. Let's follow the same process by approaching question B. So at question B, we have to calculate the probability that there are no left-handed students. Well, I'm going to scroll down and I'm going to do the exact same thing. If I have no left-handed students, no L, in mathematics that's equivalent to 0, right? In mathematics we have to use numbers, so we have to translate words into numbers. In other words, L equals to 0. So the question is effectively probability of L equals to 0. So I am going to have the same process, the binomial PDF on my calculator, and you do it on your calculator, and you put the bracket and you substitute the relevant values. The N, which is 15, so write 15 over there. The probability of success is still 0.475, write that as well. And then the X value is actually 0, so write 0. You put all these things, you should be getting 0.0000 and then 634. I still have 3 significant figures here, okay? Develop the habit of writing your answers at 3 significant figures. So that's another solution, another answer. And now let's have a look at question C, which is slightly more difficult. So in question C, we have the following. What is the probability that there are more right-handed students than left-handed students? Okay, I'm gonna go here and offer you guys a solution. You have right-handed students, left-handed students. Now, you have 15 students in total. As you can imagine, since we work with left-handed students already, I need to find how many right-handed students there are relative to 15 and L. Well, since I have L, the number of left-handed students, right-handed students must be the difference, 15 minus L. That's logical. So I have 15 minus L representing my right-handed students. I want to know the probability of having the amount of right-handed students greater than the number of left-handed students. Okay, no problem. We write it like that. And then we're going to do some substitutions. 15 minus L greater than L. Solve the inequality. Add L on both sides. So you have 15 greater than 2L. Keep solving. Divide both sides by 2. 15 divided by 2 is 7.5. 2L divided by 2 is L. In conclusion, you can say now that L is going to be less than 7.5. Is that good enough? No, it's not. Why is it not good enough? Because we are solving a binomial probability distribution question. We need discrete values. I have an interval using a rational number, and we know that discrete variables have to use integers. So I'm going to continue and say that L must be less than or equal to 7. L is going to be integer values less than or equal to 7, because 7, it's the first integer lower than 7.5. Now this is much better, because I can use this information and put it into my calculator in the following way. I'm gonna say that I want the probability of L to be less than or equal to 7. Now keep in mind, guys, the following. Pay attention to what I have to say now. Because we have an interval, meaning we have inequality, I'm going to use the binomial CDF, not PDF like before, CDF. CDF stands for the cumulative distribution. So binomial CDF, which is also on your calculator. You literally have to just scroll one level below. So in the binomial CDF, they're going to ask you for the following things. They're going to ask you for the number of trials, the probability of success, the lower bound, and the upper bound. So fill in those values. That is going to be the following. You still have 15 as the number of trials. You have 0.475 as the probability of success. The lower bound is the minimum value that this variable can take. Well, the minimum value in the context of students is 0. You cannot have a negative number of students, so that's going to be 0. The upper bound, or the upper value, is going to be 7 included. You see, I have the equality sign as well, so I'm going to put 7 because it's included. On your exam paper, you're going to write binomial CDF in the following way and put the actual bracket with the values in the order that you see here from top to bottom. 15, 0.475, 0, 7. Close the bracket and just write the answer from your calculator, which would be roughly 0.578 rounded to 3 significant figures. That is the answer to the question. So for you to be effective with your IB studying for this course, and you want to use my content, use this video and pause it whenever you need and look over your answers, look over your solution. Use this video to check yourself. Go back and forth exactly on the parts you need, part A or B or C. That's why I do it, so you can have at your availability pretty much a non-stop teacher. All right? Thank you guys for watching. I'll be posting every single day. Hope this all made sense, and we are done.